Good morning. Today we are diving into one of chemistry's most practical concepts, density. Before we start, let me ask you this. Why does ice float in your drink but a penny sinks to the bottom? By the end of today's lecture, you'll understand exactly why this happens and how to calculate density for any substance you encounter. Let's start with the basics. Density is simply the amount of mass packed into a given volume of space. Think of it like this. Imagine you have two identical boxes, but one is filled with ping pong balls and the other with bowling balls. Which box would be heavier? The bowling ball box, of course, because it has more mass in the same volume. The mathematical formula for density is D equals m over v, where D is density, m is mass, and v is volume. We typically measure density in grams per cubic centimeter or grams per milliliter. And here's something helpful to remember. 1 cubic centimeter equals exactly 1 millimeter. What makes density special is that it is an intensive property. This means it doesn't matter how much of a substance you have, the density stays the same. A drop of water has the same density as an entire swimming pool of water. Now let's move to why different substances have different densities. The density of a substance depends on two main factors, the mass of its atoms and how tightly they are packed together. Heavier atoms generally create denser substance. This is why gold at 19.3 grams per cubic centimeter is much denser than aluminum at 2.70 grams per cubic centimeter. But atomic mass isn't the only factor. Atomic packing is equally important. Think of it like packing a suitcase. You can fit more items if you arrange them efficiently. In solids, atoms arrange themselves in specific patterns called crystal structures, and some patterns pack more efficiently than others. Temperatures also plays a role. Generally, as temperature increases, substances expand and become less dense. This happens because atoms move more vigorously when heated, taking up more space. But here's where it gets interesting. Water is special. Here's one of nature's most important exceptions to the rule. Ice has a density of 0.92 grams per cubic centimeter, while liquid water has a density of 1 gram per cubic centimeter. This means ice is actually less dense than liquid water. In liquid water, H2O molecules are randomly arranged and packed closely together. But when water freezes, something fascinating happens. The molecules from a rigid hexagonal crystal structure held together by hydrogen bonds. This creates a beautiful organized pattern, but it's actually less efficient at packing molecules together. Think of it like this. Imagine people standing randomly in a room versus people arranged in a formal dance formation. The dance formation looks more organized, but fewer people fit in the same space. This density difference is crucial for life on Earth. Ice floats on water surfaces, creating an insulating layer that protects aquatic life during winter. Fish can survive under the ice because the water below remains liquid. Now let's put this knowledge to practical use. The density equation D equals m over v can be rearranged to solve for any variable. If you need mass, use m equals d times v. If you need volume, use v equals m over d. The key to success with density problems is to identify what you are given. Choose the correct equation form and always check that your units are compatible. When tackling density problems, follow the systematic approach. First, identify what you are given: mass, volume, or density. Second, choose the correct form of the equation. Third, substitute your values with units. Fourth, make sure your units are compatible before calculating. Finally, check if your answer makes sense by comparing it to known substance. These calculations have real-world applications everywhere. Engineers use density to design ships that float properly. Forensic science identify unknown substances by measuring their density. Even in your kitchen, oil floats on water because oil has a lower density, typically 0.8 to 0.9 grams per cubic centimeter. Common mistakes include unit confusion and forgetting significant figures. Remember, your answer should reflect the precision of your measurements. Let me walk you through a quick example. Suppose you have 50 grams of metal with a volume of 25 milliliters. The density would be 50 grams divided by 25 milliliter, which equals 2 grams per milliliter. This is all for this lecture. See you in the next lecture.